Hey y'all, today, since we've already done confidence intervals for means, we're going to talk about hypothesis tests for means, and we'll call that a one sample t-test. So the assumptions and the conditions are the same as we talked about in the last lesson for confidence intervals. The way you calculate the standard error is the same. You take the sample standard deviation, divide by the square root of the sample size. The only thing that's going to be a little bit new is calculating your standard statistics. So before we were calculating a z-score, now we're calculating a t-value with a specific degree of freedom. And so we just use our sample mean, we subtract our hypothesized mean, so the mean we use for our null hypothesis, and then just divide by that standard error. So if you go to page 587, we're going to do an example. So we're going to piggyback on the confidence interval we made in the last lesson about the amount of sleep that college students get every night. And this one sleep study is saying that they should get at least 7 hours of sleep. And so we want to test a hypothesis of whether or not the students are getting enough sleep or if they're getting less than that. So we've already checked the assumptions and conditions for this scenario. We have a random sample, less than 10% of the population is sampled, and we looked at the histogram or the probability plot and found that the data was approximately normal. So we got to write our hypotheses. We're going to use mu, that Greek letter, for mean. So our null hypothesis is going to be that the mean is 7 hours. The alternative is going to be that our average amount of sleep is less than that 7 hours. And we'll use an alpha of 0.05 because they're not specifying what to use. We've already inputted the data last time. We did one variable statistics to find the sample mean, sample standard deviation, and we made the calculation to find the standard error. So we're going to use all of those again. Now we need to calculate our t, which is just like calculating a z. We have 24 degrees of freedom. So sometimes we'll just write it as t24. So we take our sample mean, subtract from it our hypothesized mean, and divide by the standard error to get a p of negative 1.67. So now in order to calculate a p-value, we have to do a one sample t-test. So if we do stat tests, we're going to do number 2 here that says t-test. We're going to use the statistics we have. Our hypothesized mean is 7. Our sample mean 6.64. Sample standard deviation 1.075. That's all stuff we calculated last lesson. And our sample size was 25. I'm going to choose a less than because that's what my alternative is. So if I go down and I calculate, I get a p-value of 0.0535, so on and so forth. So our alpha was 0.05 and our p-value is 0.054. They're really close, but we don't have the evidence to show that we should reject, so we're going to fail to reject. No. So since the p-value is greater than alpha, we're going to fail to reject, even though it's really close. So we can say that there's not enough evidence to show that students are getting, on average, less sleep than recommended. Now, since they're so close, what the people performing the study would probably do is take a new sample and run this test all over again. There is statistical significant evidence to fail to reject, but this might make us want to try again just to make sure that we haven't made a type 2 error. So another thing that we can do if you look at page 592 is we can determine a sample size that we might want to select when we're constructing a confidence interval. So we're going a little bit back to confidence intervals. Our margin of error for a confidence interval for a mean is t star with the degrees of freedom times that standard error. But since we need the sample standard deviation to calculate the margin of error, if we don't know how many individuals we're sampling, we don't know what n is. We don't know what n minus 1 is. So we are going to use z star like we did for proportions, and we'll use sigma. So in this example, we have we think we know what the standard deviation is. We think we know that it's 10. And a z star for 95% confidence is 1.96. They want their margin of error to be 8 minutes. And so it's incumbent upon us to just solve this for n. Okay, I simplified this, cleaned it up. I did 1.96 times 10. Multiply both sides by the square root of n. Divide both sides by 8. And then square both sides to get n to be 6.0025. We'll always round up. And so what I should have written there was 7. So we will do 7 trial downloads. So very similar to what we did when we wanted to find the sample size for proportions. So that's it for this lesson. Make sure you come ready with questions if you have questions, if you're confused at all, and we'll do some practice.